This is Shakil Ahmed. In this tutorial, we will discuss about missing values, and we start with how we can check for the missing values in a data set, and how we can remove the missing cases, or we can remove variables with missing values, and we can diagnose how many missing values in a row, how many missing values in a column, and then we can try to replace missing values with specific values, or even mean of the rest of the complete cases for that variable. So this is just a simple tutorial on how to handle with missing values. We are creating a data on X that consists of 10 observations, and 2 observations are missing, and Z, Y, first 2 elements are missing, and we have again 10 observations, and for Z we have middle 2 values are missing, and we have again 10 observations, and we can make a data frame, and you can check uh, how many values are missing in a data frame. This is easy for a small data set. When we have a large data set, we can't check in such a manner directly. So we need to check by columns or by variables, and then by rows we can check. So the column sum command is used to check how many missing observations in a variable, in a single variable. So you can just check. And there are two values are missing in X, two values in Y, and two values in Z. And if you want to find the percentage, you can just divide it by the n row df and multiply it by 100. So there are 20% missing in X, and 20% missing in Y, and 20% missing in Z. Similarly, you can check by rows for each observation, and we are selecting, for example, specific number of columns. We are just going to check in specific variables. If you want to check for overall data, then you don't need to uh, this constraint. You can just write df is dot na and df data frame. So, and we can check how many missing values in and different rows. So you can check for first observation only one value is missing, for second only one is missing, and for third observation there is no missing, and similarly for last observation there is only one missing value. So you can check it by row, and then remove the variable with all missing values. The complete cases command will analyze the complete cases uh, of the observations, and if any variable consists of no data, that will be excluded from your data set. Although NA omit DF also does it, but it will not exclude the variables with all missing values. So you can just use complete cases data frame. It will give the data with complete cases. You can see for third, 6, 7, and 8 observation, you can see third and 6, 7, 8 observation. In these cases, there were no missing observations. So we can just have a data frame with complete cases. And you can use the na omit command that will exclude all the cases with missing values, but it will not remove the variables if a variable consists of no data. It will keep that variable in your data set. So we get same result as there were no variable with all missing values. That's why we get the same data set as we get using complete case command. And you can also use the na exclude command to exclude the rows with missing values. And now this is same as na omit, as it will exclude every row containing even one na. You will get the same result. And you can uh, use the complete cases command in the same way. Row sum, if this is equal to 0, means if the any row consists of at least one missing observation, this is greater than 0, it will that row will be removed from the data. So it will keep all those rows with 0 missing values. This is the same command as the na omit command. And you can do further analysis just excluding the missing values that will analyze the cases with no missing values. So we can use na remove is equal to true, and we are finding mean, that is mean is 4.5 for x, and you can find mean of y, mean of z, whatever else. But it is excluded the value missing in x only. Basically, we are specifying for x only. We are doing analysis on x. This is good. Basically, we don't need to exclude all missing values, and we can just uh, apply any. If we are applying any function to any column, then the specific values within that variable will be excluded from the analysis, and we don't lose the overall data. So the next thing is you can just check the NF fail DF. It means it will the data uh, will not show if will not be shown if it consists of any missing value. You can just check. So missing values in objects. That's why it is not running. And you can visualize the missing values using visualize missing value command that is under the library with data, visualize data. And I have already installed. If you have not installed, you need to install and then visualize the missing values in our data set. So it will give the visualization of it in terms of a matrix, the number, proportion of missing values in X, proportion of missing values in Y, proportion of missing values in Z. So you will just get a visualization, a picture that tells how many observations are missing, how much values are missing in different variables. That is, you can just display with your uh, data cleaning stage in your reports. And then when we are clear that there are missing values, and simply removing those values will cause a reduced sample size and will affect your study outcome results, then you need to go for different imputation techniques. The simplest imputation technique is to replace the observations with the with the age, uh, with the mean of the remaining values in the data set. For example, if we are if a value is missing in age variable, then we can just replace it by the mean or median age of remaining respondents. Although this is not a correct way, but if the analysis is the outcome of analysis is some other variable and age is just a secondary variable, then you can do uh, this thing. Just Basically, imputation of mean is just equivalent to simply removing the mean from the data. But uh, on the other hand, we don't lose the information for other complete cases. For example, if we see the data frame, we have X is missing only in 9 and 10, and if we just remove the cases with all missing values, then it will exclude all these values. Then we are just left with 5 observations or 4 observations only. In that case, we can just replace, for example, X is not our primary variable of interest, then we can replace the missing values by mean of the rest values. We can just do it as, for example, for y variable, I am replacing the mean of y when when there is no NA. Basically, I am just computing the mean of these values at 7, 6, excluding these two values and replacing the mean in these two observations. So let's see. So this is simply a uh, we are just replacing mean is 4.5 for the two missing values in variable y, and now if we are, for example, studying the x with using the values on y, then we can use 8 observations instead of only 6 observations. So for other more appropriate imputation methods, you can see the literature, or you can use regression based imputation methods. You can use mice imputation method and hot take imputation method, and different types of other imputation methods are available, but be careful about the missingness structure. What is missingness structure? Basically, if there is a missing complete at random, that is called miss MCAR, then then imputation is okay. But if missing is not at random, then simple imputation based on regression and other things is not a good way. Then we need to go for other more sophisticated methods. Thank you for watching, and if you have any comment, you can always write in comment box. Thank you.